So let's talk about the factors that really control the microbial spoilage, which is the intrinsic factor of the food itself. And then we'll talk about extrinsic factor. Water activity of food is the ratio between the vapor pressure of the food itself and the vapor pressure of distilled water under identical conditions. You can think of water activity as an indicator of how much free water molecules that bacteria or fungi can use for their metabolism. If the water molecules are bounded by salt or sugar, then the microorganism will not be able to grow. As we discussed earlier, that bacteria and fungi have pH requirement. So controlling pH of the food, you can control microbial growth. You can also use presence of and absence of oxygen to control microbial growth. For example, anaerobic condition will prevent obligate aerobic bacteria to grow. So the aerobic environment will not be suitable for obligate anaerobics. In food industry, various technologies are used to prevent microbial growth and to prevent spoilage to extend shelf life, such as thermal process that reduce the microbial load or eliminate them altogether, non-thermal process such as filtration or HPP, and there's a filtration or refrigeration or freezing to slow down the microbial growth. And then, of course, there's vacuum and modified air packaging to prevent spoilage due to aerobic respiration. Food microbiologist knows about hurdle technology that helps obtain microbial safety and the stability of the product, and at the same time maintains organoleptic properties of the food. Hurdle technology is a method of ensuring that pathogens in food products can be eliminated or controlled by combining more than one approach. For example, you can use pH or water activity or temperature, or salt level, or combinations of those to prevent microbial spoilage. You can also combine intrinsic and extrinsic factor. For example, keeping kimchi in the refrigerated condition, right? It's a low pH, but you want to keep it in the refrigerated condition. This is a summary of principal hurdles used for food preservation. Like drying, curing, or preserving, or effort to reduce the water activity. Acidification of formulation is effort to control the pH. And then heating, freezing, refrigeration is using the principle of temperature range, and packaging like vacuum, modified air packaging is a way of alter the oxygen availability. And then of course there's a chemical preservatives that people can use. So if you're looking at this picture, there were several different types of foods. What are the control factors for this food, right? For canned food, for yogurt and dairy products, for yogurt and dairy products, what do we know? We know they do pasteurize the milk, and then they inoculated milk with probiotics that can fermentation, lactic acid bacteria fermentation. They also have other species to add in the flavor to optimize the process. And also yogurts meant to be kept in the refrigeration. So it's multiple hurdles used in this case. For baked goods, so the initial process, the baking will reduce the microbial load, right? And then the baked good usually very low water activity to keep it dry to prevent mold from growing. And then of course, acidified food use pH to control growth. And same thing with probiotic drinks. Probiotic drinks usually have low pH, and also they might have live cultures that keep pH low. Let's look at some examples in more detail, like salad bowl. So when you have this salad bowl, what are the ways they try to extend shelf life? For example, in this, say the picture, the chicken is cooked, the cheese are processed, low water activity, the corns grilled, cooked, and then salad dressing is most likely acidified dressing, and the vegetables is washed. So in this case, which components or ingredients determines shelf life? The ones that goes bad first, right? If you purchase salad bowl for lunch, if it go bad, you throw away. But which of this component can go bad, right? In my experience, is usually the vegetable, because the washing itself is can reduce the microbial load but not eliminate it. And so, what is the control? How we can extend shelf life of salad bowl? Which is normally we see is the refrigeration. You can keep it in the refrigerator for 5-7 days. In beverage, the processing of beverage, including microbial reduction steps, right, like water treatment, filtration, and some beverages have pasteurization process. And then the controlling factor usually is pH. They keep the pH very low. And then in some beverages, they add preservatives. And then for soft drinks, they use carbonation to inhibit microbial growth. And then in some other beverages, like fruit juice based, they may require refrigeration. How about butter? What's the spoilage mechanism of butter? So butter usually have low water activity and high because of high fat content. So they're not easy, they cannot be easily contaminated or spoiled by microorganism. However, if you add things to the butter, if you add fresh herbs, that's actually increase the baseline microbial load. And what happened to those bacteria or fungi introduced by the fresh herbs? That's something we need to look at. Would they change the water activity of that niche area so they can have a really small space for them to grow, or the low water activity of the butter really helped it prevented them from growth. And also you can add salt to the butter to as a measure to inhibit the reduce microbial growth potential. And most of butter we still say keep it refrigerated. Salad dressing, the control factors of salad dressing usually low pH. Low pH is good control most of bacteria, but we know yeast, mold, and some lactic acid bacteria can tolerate low pH, so they may be able to grow. So in some salad, they use preservatives to help prevent spoilage. And then they can also refine the process of making the salad dressing, like hot fill or other water treatment, other things, environmental control. And then some salad dressing may require refrigeration to ensure the shelf life. We usually say canned food is safe because the two factors there is thermal processed to ensure the kill of, if not all, then most of the bacteria. They may some spore formers survive, but mostly we say the thermal process is through, is validated, and then the hermetic seal, right? They should not allow any bacteria or fungi enter the can after products released to the market. However, if something goes wrong during the process, then you will have spoilage on your hand. For example, if the thermal processing is insufficient, then some spores survived and they were able to grow. If the cooling is insufficient, then thermophilic spore formers can germinate and grow. And if there's a post-processing contamination, for example, the can has seals not properly, has liquor spoilage. And also if you receive the ingredients that already spoiled, and then you have intertoxin there, and the process cannot kill intertoxin, you have your not only spoilage but the food safety concern.